All right, well, let's get this show on the road. I'd like to pick up by talking about the upcoming assignment due in a week, which is basically to create 4 blocks on your own of things in your house or here at school, however you care to do that. And what I'm asking you for is to really pay attention to something, not just to sketch it, but to really think about its dimensions and its proportions. And if it has curves that are hard to measure, how do you draw the curves so that what you've drawn looks like what's there? And just to flip over onto the back, I've given an example of one barely adequate sketch of an easy chair in plan. And then down at the bottom, probably the best assignment I've ever had anybody do with this, which is a little speaker, a tape holder, a webcam, a calculator, or something or other. I'll zoom in. Pretty great, and that's students' 4th assignment. The level of detail and accuracy, this is probably a pretty good example. Let's not do a teacup in elevation or a coffee table in plan. You know, up the ante. And as I say at the bottom of the sheet, surprise yourself. I think the person who did the chair probably did not surprise him or herself. I think the person who did these, by the time she was done, was delighted. I guess there are 3 stages to drawing something accurately, like the grill on the Bluetooth speaker. First would be seeing the grill and deciding that you want to include it in the drawing. The next would be analyzing how it's put together, the actual thing. And then 3 would be, how do I make that happen in AutoCAD? What I'd like to do today is go over, AutoCAD is not a graphic design tool, as you're probably aware, but we're going to make it do whatever it can do, incorporating areas of hatch as well as solid color, transparency, controlling the order of things as they're stacked, gradients, images. I wanted to talk a little bit about comparing drafting to graphic design. And in the set of drawings from the Cincinnati train station, which is now the museum, those drawings managed to be beautiful in and of themselves, although they were not intended as graphic design in the sense we think of it as book covers or poster art, something like that. But generally, and I guess this is the crucial difference, is that when we're drafting, what we produce, our drawings are just tools towards the end of getting an actual thing built, an instruction set. It's not the end result. Whereas in graphic design, it is the end result. Maybe your image ends up on a book cover, but it's still the image itself is what you're producing. But there are times when, especially like on title pages, or you're doing the first page of a presentation that you're going to put either online or as one of your projects, you might want to use one of the CAD programs since you're already there to do whatever it can do to sort of jazz things up. And I'd like to explore those options. Let's talk about hatches first. I'm just going to zoom in here just to use this, the hatch command, which is just H here on the command line, H for hatch. And if your ribbon is, let's maximize it so we can see all of this going on, because this is where we'll sort of be working here today. AutoCAD provides several major types of hatches. One would be schematic hatches, usually composed of parallel lines at some scale or other. And traditionally, double lines at 45 degrees. Crank this scale up to be like 20 or something. 2 parallel lines like that, and then a gap, and then 2 parallel ones is used to represent steel in a section. If you cut through a beam at some high level of detail, you'd show this with 2 parallel lines. And that still doesn't look like that. That's just a convention that pretty much worldwide, people looking at drawings will know that represents steel. In any case, a drawing set would have a key. It would have a little box saying double lines mean steel, single lines mean something or other else. Dotted lines mean something or other else. So there'll always be a key to make it clear what's going on. Other kinds are more figured. Let's get rid of these. This is American National Standards Institute, and these are the ways it suggests that materials be represented. And there are other ones. Let's go down to the brick one, where we'll give it some sort of scale. where it sort of starts to look like either brick or cinder block in an elevation. There's something like a representation of that thing. And we also get those with shingles. We can scroll down. Oh, there we go. That's what I wanted. You know, there's the sort of the nonsense one here of an Escher. So we can have sort of generic representations, ones that actually recall what the material is that we're trying to call out. And then, as you know, there's solid ones. Just up at the top, isn't that the solid? And no amount of zooming will reveal that. That's just there. And then there are also gradients. Did you deal with these at all with him? Okay. H. We can do gradients that go, any two colors can have basically these kinds of patterns. And I'll pick this one right now. Linear. Just drop it into place. And with that, we can then choose what its colors are. If I want it to go from orange to yellow, I can just flip it like that. So that starts getting kind of interesting. We got a color plotter. Let's use it. People use these a lot last year for backgrounds for their boards, sort of a wash going maybe from pale blue to slightly darker blue, that just as a background for everything else to sit on, which is sort of nice with a light image sitting against that. It really pops out and you can sort of tell where its edges are. And then with these also, we can choose if we want to have a different pattern. Let's see, say I want to do it circled, I can change these to a different gradient or indeed a different hatch pattern. And I think for, if I were doing this for a presentation, I make up some layers, just, called like title page hatch or something like that. So they wouldn't turn on and off with other objects or worry about the color. But if I'll make a layer here, here's the button for new layer. Yep. Let's call this hatch red. And I'll change it to red. So then I can put this hatch onto layer hatch red, and it'll turn red. And again, you really don't want to be putting on a layer that's really named like hatch red and then change its color independently to magenta or something rather. You don't know, you're turning things on and off and you can't tell what they are anymore. So we'll Control Z and leave that back on the red layer. So in that respect, they behave just as if they were that many lines drawn in terms of how they behave. When you create a hatch, you have two choices of whether it's going to stretch, expand if the boundary that defined it changes. For instance, in this case, it was. You might not want that. Let's just do circle. And if I do hatch again, and so associative means that the hatch is associated and remembers the boundary used to create it. If we turn that off, hatch, turn associative off, then create a hatch. And I'll crank this up. If I do that and expand this, the hatch does not go with it. So it's just a choice of how you want that to work. Now, this whole time when they've been coming in so tiny like that, I realized that I had set these up not to pay attention to the scale of the drawing that they're in. And we are here in this, right now, we're looking at this view with everything sized as if it's going out to be at 1/4 of an inch equals a foot. If I go to hatch and turn on annotative, that means the hatches will pay attention to the current scale of the drawing down here. So let me turn both of those on and pick a different place. And you can see that when they come in, they're now scaled larger. I guess they're probably 48 times as big since we're at 1/4 inch equals a foot. And you can start to see how those will show up at that scale. Instead of having to multiply everyone by 20 or something or other. This one was, I had to scale. This one I did not have to scale because I had changed it to be an annotative hatch, meaning it responds to the scale of the view that it's in. And then there's something I'm calling graphic emphasis for planning or presentation purposes. You might want in a floor plan of an office space, for instance, to have all of the manager's offices with a light green background and all of the secretarial offices to have a light yellow background and the bathrooms have a light blue background, something like that. So it's really clear how those areas relate to each other. If you got some management here and some management here, it's really easy to see if they're separate colors. You might realize, no, I'd really rather move them up together. So helping the client and you understand either what they have or what they're getting. Creating a hatch always starts with some sort of bounded area. And you can either pick an object to have that done, or you can pick a point inside the area to be hatched, basically just sort of shooting rays out until it hits a line and stopping there until it's got that. If we try to hatch out here, for instance, it says, sorry, you're off in space. There's no edge there. I would have to hatch the drawing all the way out to the, to Pluto or somewhere. But if I put a rectangle around this, rectangle, and then use the hatch command, now it can find it because there's an edge. It just shoots till it finds pixels. Each of these hatch patterns can have two different colors. If we select it and decide that we would like to have this not only with our sort of our tiles marker, but we would like to have a light gray background behind that, we can say, once that's selected, pick a background color, and maybe I'll go down to select a color off of here and pick a light gray. Okay. So we don't have to do two different patterns. We don't have to do a light gray hatch and this one and get them to line up on top of each other and stay lined up. It's just one that has a background color and a foreground color. And you can switch those if I want my foreground color at this point to be, if I want the foreground color to be white, I need to change that object to white or put it on a white layer. Well, let's just try that. Let's make a new layer called hatch white. And I'll make that be, well, essentially, let's go here to 2-color and just take it all the way up to white. Okay, there we go. So then if I put this onto the layer hatch white, it will change the lines, but not the background color. So you start to get any sort of stuff you want to do that way. So it starts opening up what our options are here. Hatches can be rotated. Rotated right somewhere in here. We can rotate them. Oh, angle. 45. Whatever you want to do that way. We have another possibility with all objects, not just hatches. Copy. Let's copy this to there. And right now, it looks like we have the red sitting on top of the gray. And AutoCAD always puts anything that's new, I just created this hatch over here, visually on top of what's been there before in what's called its draw order. And if you want to reverse that, we can select the object. Let me see if I can just right-click it. Draw order right here. Select an object and right-click it. And then I can say bring it to front, which is basically sitting on top of everything else visually. There's no actually 3D separation going on. It's just how this gets processed visually. Or I can say send to back. And now it's behind that gray stuff. If I want to see it coming out a little bit, maybe what I'll do is take this one and right-click. I'm looking for transparency. Maybe I have to set that layer to be transparency. Let's say the hatch white layer has plot style transparency, let's say transparency of 50. Okay, so there we get the red showing through a little bit of that. Maybe I'll change that to transparency being only 10. Maybe a little more, 20. So with all objects, not just hatches, we have those options of stacking, i.e. draw order, and transparency / opacity that you can use for whatever design kind of things that you want to do. Let's talk about how text and hatches interact. Text. Text. If this were a room and I was hatching it with a gradient or something, hatch, I'll pick a solid, and I'll make it by layer, and I click inside of here. When AutoCAD sees text or sees dimension text, it will leave an unhatched area around that. Let's do it again. Hatch. Okay. Hatch. Cannot evaluate hatch boundaries at all supported scales. I don't know what that means. Well, anyway, it's supposed to, if I figure that out, let me just note that for next week. So the way this is supposed to work, when you hatch an area that contains text, the text itself will not be hatched. You can move the text and its white background travels with it. When you move text onto a hatch that had previously been created, it will not acquire a white background, but editing the hatch with the hatch edit command, HE, and adding the text to the hatch will open up the white background. If you want to be able to look at your line drawing here and turn off all the hatches temporarily, the fill command is just a toggle that turns them on and off. Fill, and we have two values, on or off. And then after such a major change to the display, you need to regenerate the view with the regen command, RE for short, to actually clear the hatches from the screen. They're still there, they're just turned off. And it's not even like it's doing it by layer, it's just doing it by the type of entity that is. Let's do fill on, regenerate, there they are. And lastly, something we can do, if this were truly a wall of cinder blocks represented that, they don't just start anywhere. They would start with like this corner of one block being down here at the corner of the wall. So we can reset the origin of these where the alignment of the hatch with the object would be important. So if I pick this, right click, set origin, then I come down and click here, and we can realign that basic pattern with the corner of the object itself. And that's going to be helpful for especially for tile on walls when you're doing an elevation of behind a kitchen counter or something like that, to get the tile starting where it's supposed to happen. And then let's say we want to customize this particular piece of wall a little bit. I've got these lines here already, but I want to edit them further. I can select this, right click, and explode isn't here, but I can just use the explode command just as I can do with a block. explode, take this, and it turns these back into individual lines that maybe I want to draw a circle there and erase that and have anything I want to happen in there. So you can explode those blocks, explode those hatches, and then edit them as desired. And lastly, sometimes you just want to hide some stuff. You've drawn it, you don't want to get rid of it. Maybe you want to see it in some other view, but not in this view. And so there's what we call a wipeout, which is just like a white opaque area that sits on top of everything else and can then obscure it. And that's with annotate. You can just type wipeout or use annotate wipeout right here. And we can just draw a shape. I'll draw a polyline like that. It's really just a white solid hatch. And it'll give us that shape. Let's see what draw order does. If I use this draw order, send to back, then it'll be underneath it. This is still partly transparent, so we see the outlines of that. I'm going to bring it back to the top with undo. And if we even want to get rid of the edges of that, it's on layer 0. I can use, let me experiment with this for a second. Wipeout. Wipeout F for frames, off, and that will turn all the frames off visibly, although we can still pick that object. Okay, so where did it just go? Boy, a lot going on here. Control Z. It says here, use the frames option of a wipeout command to control on-screen and plotted visibility. Wipeout, can I right click and get frames on this guy? No. Wipeout, frames. We can turn them on, we can turn them off, or we can display but do not plot. Let's try that. So when I went to plot, I wouldn't see those guys, but I can still see where it is. Now draw order. Front. There we go. So some playing around to do there. I haven't messed with this for, I do this once a year, as maybe you can tell, but these are sort of the options that are available to us. In the same way that we explode a hatch and modify it, we can also explode a piece of text into lines and polylines for any further graphic editing we care to do. So I'll create a small piece of text. I'm going to use this Roman font and set it current, which uses a font that is called Roman S for Roman simple, and then SHX means that it's a special shape font provided by Autodesk. And we can see that there are a bunch of true type fonts here, which are the same ones we get, they're the ones from Windows on this system, identified with the TT icon. And we also have the Autodesk SHX shape fonts identified with the icon of a drawing compass and the small letter A. So we have Roman complex, Roman double, and Roman simple. These are the ones that are actually composed of straight line segments, so they can be plotted fast on a pen plotter, and they look terrible, but you'll see. We'll stay with this one. Okay, we'll set that to be current and close, and then I'll create a piece of text here. S font. Okay, so there's that. And if you look carefully at it, you can see that it's made up of line segments. And if you need to play with this or do something special with some letters, we can take this, and up in Express Tools, we have the option to explode text from whatever it is back into lines. So now that turns into a polyline. That turns into, I guess these are all polylines with 2 points or more points on them. It gets more interesting when we start doing a style that uses a true type font. Let's just pick Arial since we know what it is. Set current, close. Text 0 Arial. And we can explode these too, but we won't get a single line. We'll get some perimeters, and actually each of these will be a couple of polylines. If I go back to Express Tools, Text, Explode Text, I can do that, and now we see the outlines that those letters were made with, and you'll see that it's a couple of closed polylines. So if you want to turn these just into outlines of things, all we have to do is trim away these extra lines, just with trim, TR. You just have to pick these a couple of times because they're the edges of several different objects. Anyway, but now you can take those forms and do whatever you need to do with them. Rotate them individually, or hatch them, or stretch them, or curve them, or whatever needs to happen. They don't function as text anymore. They just function as lines or polylines. The last thing I would like to do is to talk about putting images into a drawing. So that's just with the image command, which brings up the external references palette. Go to Image, Attach Image, pick the image, Open. OK, place it, and scale it. The Image Frame command can turn the edge on and off. To conclude, I want to go over a basic procedure for creating the blocks that are most of assignment number 4. For demonstration purposes, we'll use one of the plastic plugs that hold a roll of plotter paper in its shipping box. Its overall dimensions are 4 inches by 4 inches, and it has a 2-inch diameter circle at its center. Its thin ribs are 1/16 of an inch thick, and its flanges are all 3/8 of an inch wide. First, I'm going to draw a 1-inch radius circle at the origin of the drawing, just so I know where that is. And a couple things about this icon here of the coordinate system is it's sort of floating right now. It's not actually staying on the actual 0, 0 origin of the drawing. It's just sort of indicating which direction X and Y are. But if we want to see where our actual center of the drawing is, which will be the handle for this when we're placing it in the drawing, if we type UCS icon, and this is the user coordinate system, this little XY crosshair. And if we say put this at the origin of the drawing, it will appear there if that 0, 0 point is currently visible on the screen. Otherwise, it parks itself in the lower left-hand corner, as here. If I zoom out until it's visible on the screen, then we can see it as the origin of the XY coordinate system. Anyway, you can see that there, I have this sort of red line going out in the positive X direction and the green line going up in the positive Y direction. And this actually is the 0, 0 origin of this whole drawing. So I'll just zoom in there. And the reason I'm going to make this point be 0, 0 in this block is when we end up placing this back in our drawing, the cursor will be right there and we'll move it around by its center point. If we let the center point be down here, I'd be moving the cursor here, but the block would be off it, which is just very disconcerting. You like to have this in some intimate way connected with the object itself. So just for my reference point, I'm going to do circle. Center point is 0, 0 up here, which is this, the origin of the drawing, and the radius is 1. Diameter is 2. There are a couple of ways to draw the rectangle. I think I'm just going to do it with lines. If I do a line from 0, 0, and just come up a bunch, it doesn't really matter. I know that that line needs to go 2 inches in each direction. So I'll offset it 2. Then I'll draw a line from here to here. Offset that 2. 2 up and 2 down. Get rid of these guys. And then use fillet to trim that out. Okay, so let's do our corner geometry. The radius here looks to be about 1/2 of an inch. Let's do that. Let's fillet these with a radius of 1/2 an inch. So fillet. And then I want to change, right now the radius is 0, so things will meet at a right angle, which they're already doing. So I want to type R for radius and make that be 0.5. And I can do these guys. Spacebar repeats the fillet command. But I know I need to offset this 1/16 of an inch out, and then offset these guys 1/16 of an inch in. A question from the floor about filleting with a radius. I started the fillet command, fillet, and then I can either click on the radius button up here or just type R and enter. And then put in the radius that I want to have. And with any of these prompts for any of the commands, if it's showing you a distance or an option in the angle brackets, you can just enter to accept that one without having to type it again. Or if I wanted to make a radius be 2 inches, I could type 2. But here I just hit enter because I want to keep using the 1/2 inch, which is what it had before, and we'll get that. So I think I'm just going to work on this quadrant up here and then mirror that instead of redrawing over and over again. First, I'll start getting the thicknesses of these things. So offset, what is it? Offset. If I wanted to keep offsetting 2 inches, I could just hit enter, but I don't. I want to like offset 1/16 of an inch. So we'll kick that out. And I have it to the outside. And offset is one of the repeating commands. So I click that in there, that in there, and that in there. So to get my vertical leg in, whatever that is, I'm gonna draw from the 0, 0 point. So a line from 0, 0 up to here, anywhere vertical really. This is going right up the middle. I actually want ones to make them 1/16 of an inch apart. I need to offset this guy a 32nd and a 32nd in each direction. So our total will be there at 1/16. So offset 1/32, kick this over to here, and then kick it over to there and get rid of the middle one. And I'm going to use trim to get rid of these extra pieces, TR for trim. And then really this exactly the same procedure, except going horizontally, doing one straight from 0, 0 out to the edge, and then offsetting each of those a 32nd. Now here's something. No, I wanted to offset the 32nd, as I type offset, and the number it's giving me is 1/16 of an inch, and that's not how much I want to offset this. I want it to be a 32nd, and the reason it says 1/16 is in the units of this drawing, the precision that AutoCAD is going to report distances has been set to 1/16 of an inch. So anything smaller, it's going to round off to the nearest 16th. So really, we want to come into units for this drawing. We don't really need to do it for the room. units and set our precision to a 32nd of an inch. So now when I go to offset, it'll display this distance correctly, what I want it to be. So I'll hit enter to accept that, click up and click down and get rid of this guy and trim it out. And lastly, we've got the 45, which is a line from 0, 0 if you remember, there are a couple of different ways we can do a line at exactly 45 degrees. In this circumstance, one of them would be I could just snap to the middle of that arc, which is exactly there. But if that weren't conveniently there, I could type, let's just give it some number, from where I'm at, go, let's say 3 inches at 45. 3 inches at 45 degrees, and that's one way to do that. Or if you don't like typing, which I don't anymore, I can turn my polar tracking on. See, a lot of things about this program, and set the angles that it will snap to to 45 degrees. So with that turned on, I can type line, and I'm tired of typing 0, 0. So I can just type, I would like to pick the center of this, be able to pick the center of the circle. So I'll turn centers on as one of the things that I can snap to in my object snaps. So line, turned on. Center, why didn't it do it? Oh, line. The reason when I'm on these arcs that it's not picking up the center of the circle is that it's just closer for it to pick up these nearest points or the midpoints. If I actually come down to the center of the circle, it picks it up and gives me a green dot. And then the green line caused by our polar tracking will give me the angle that I want to go. So, to draw that, I really didn't have to, if I have the drawing set up right, know what I'm doing, I never have to enter a coordinate or enter a length or an angle. I can just click to the start point and click to 45 degrees just to make that happen right off the bat. These as well will need to be offset a 32nd of an inch in each direction. Offset 1/32, accept it, click, 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 erase the middle guy, trim, and trim. So what I think I'll end up mirroring, I'll leave this circle where it is, but I'll mirror the perimeters of this space and the perimeters of this space, and we can erase everything else. Looks like a step backwards, but not when you see how this is going to work out. So we'll basically mirror this, all that stuff, well, not including that. A way not to include this, as I sort of put a window around those 8 or 10, would be to turn this whole object into a polyline, and then just not pick the polyline. So I'll do modify join, pick these guys. So now they're one object. So when I go to mirror these, it won't select that arc up there. And then I'm going to mirror this about, let's say, about this vertical axis. So I've finished picking them. I hit enter. And then the first point of the mirror line will be the center of the circle. And I got O snaps turned on so I can pick the center and just go straight up. I've got polar tracking turned on. So, my cursor will snap to that. Escape. Oops, control. I have to hit enter or something. Oh, I know what it was. There's always this question you have to ask at the end. Mirror. Erase source objects, yes or no. And you just hit enter to accept no. And then we can window all those guys and mirror them down. MI for mirror, window, click, snap, erase source objects, no. So there it is. And I think that's a pretty good exercise. Well, it really helped that it was symmetrical. that took a lot of the, if we're doing the tape dispenser that I showed you on the back of the homework, that was, more of a deal. So let's complete this process. Let's save this now as plotter paper roll support or something. So we'll go to File, Save As, and I'll stick it here on my desktop. I'll stick it in Documents just to be a little better about it, and call it paper roll plug. I'll know what that means. Save. Okay, we're done with that. We can close it out. Go back to one of these other drawings. And when I go to Insert, to go look for it on disk is this button up here. File Navigation dialog box, and we'll go to Documents. There it is, paper roll plug drawing. Okay, looks good. Okay, open. And now you see that the handle where our cursor was the origin, was the 0, 0 point that we were using when we were creating it. So I'll go stick it down here. Stick it in the student lounge. And if we don't want it on, something I forgot? I should have drawn each of these objects on layer 0, which I did, and set their properties, color and line type, to by block. So this would really behave well. So that's something I'll be looking for on your homework. Seeing this, I realized I forgot to put the holes in the plug. Always check your photographs. From my measurements, I know that all the flanges are 3/8 of an inch thick, so I'll offset first the outside and then the inside perimeter to get those. Then draw a center vertical line again, which I can offset 3/16 of an inch for half of the center flange. And a 45-degree one for the angled flange, and offset it the same amount. Then create the first hole by filleting the edges with what I eyeballed to be a 1/8 inch radius and trimming or erasing any excess. Then to make the hole easy to manage, I'll convert its separate segments into a single polyline with join, and mirror it using the angled line this time to fill the upper right quadrant. Get rid of my 2 mirror lines, and then mirror the holes first using the vertical axis and then using the horizontal axis. So at this point, I'll save the plug to disk again, replacing the previous version that didn't have holes, and then reinsert it into the plan of the ID suite, accepting AutoCAD's offer to redefine the version that is there with the new one.